Welcome to another interesting video. Thanks for watching this channel. In the previous video we discussed LCM, least common multiple. This time around we shall be talking about highest common factor. Highest common factor. At the end of this video, learners should be able to 1. Find highest common factor of numbers. 2. Find the highest common factor of algebraic expressions, meaning that what you are expected to gain from watching this video is ability to be able to find the HCF of numbers and algebraic expressions. I remain your mathematics instructor, Abdullahi Opeyemi Falade. Let's start. First and foremost, we need to talk about factors of numbers. Factor simply means numbers that divide another number without any remainder except 0. How do we mean by this? Examples. You can see the factors of 10. Those are the numbers that can go in 10 without any remainder except 0. So you start from the smallest natural numbers, which is 1. Start from the natural number 1. So in this case we have 1. 1 goes in 10. Yes, 2 also goes in 10 5 times. 5 goes in 10. So you can start by saying 1. Does 1 goes in 10? Yes, 1 goes. 2 in 10? Yes. With 3 goes in 10? No. 3 goes in 10 3 times, remainder 1. And the definition of factor is number that divides another number without any remainder except 0. So the expected remainder will be 0. So in this case, if 3 should goes in 10, it's going to go 3 times and the remainder is 1, it's not 0. So 3 is not a factor of 10. 4 goes in 10 2 times, remainder 2. So 4 is not a factor of 10. 5 goes 2 times. So you can see that when 5 goes, it goes 2 times, and you can also see that we have for 15 factors of 15, we have 1, 3, 5 and 15. So you can see that the number itself goes in itself with a remainder 0. So factors of 20, we have 1 goes, 2 goes, 3 will not goes straight in 20, 4 will goes, 5 will go straight in 20, 6 will not go, 7 won't go, 8 will not go, 9 will not go. 10 is also part of the factors of 20, but it was not included here. So 10 is also a factors of 20 before you now write 20. So moving on to the factors of 36. You can see the factors of 36. 1, 2. We have 1. 2 goes in 36. 3 goes in 36. 4 goes. 5 will not go in 36 without a remainder that is not 0. So 5 will not go, 6 will go, 6 in 36 is 6, 9 will go, 12 will go, 18 will go, and 36 itself. Moving on to the factors of 60, we have 1, you can see 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, 60. So you should be able to justify that all these are factors by dividing by 60, and you will observe that it will all go straight in 60 with the remainder 0. So this is what we mean by factors of number. Now let's now move on to common factors. From example 1, what are the common factors of 8, 12 and 16? How do we find the common factors of 8, 12 and 16? So the first thing is you have to start with the factors of 8. What are the factors of 8? 1 goes in 8, 2, 4 and 8 itself. The factors of 12, 1 goes in 12, 2 goes, 3 goes in 12, 4 goes in 12, 6 goes in 12 without any remainder except 0. 12 also goes in itself, 12 goes in 12. So factors of 16, that's 1, 2, 4, 8 and 16. So these are the factors of each of this number, 8, 12 and 16. So what are the common figures? You can see 1, 1, 1. That's why we have 1 to be one of the common factors. 2, 2, 2. That's why we have 2 to be one of the common factors. 4, 4, 4. Is there anything like 333 all true? No. 88 all true? No. So we are left with only 3 figures, 1, 2, 4. So the common factors of 8, 12, and 16 are 1, 2, 4. Let's look at the second example. What is the highest common factor of 8, 12, and 16? Like we have done in the previous example 1, we have been able to see the common factors of 8, 12, and 16, which is 1, 2, 4. Out of these 1, 2, 4, which one is the highest? And that's the result 4. So highest means the greatest among the common factors. These are the common factor 1, 2, 4. The greatest among the 1, 2, 4 is 4. So hence our HCF, which is the highest common factor of 8, 12, and 16, is 4. Interesting. Wow. That's just it. Very simple. Can we proceed? You said yes? Okay, let's move on. Now, let's look. Is there any other way by which we can get the HCF apart from this first approach? Let's use another approach. What is the highest common factor of 8, 12, and 16? Using an alternative approach. In this case, just like in the LCM, but in this case we are more, we lay more emphasis, we prioritize figures that goes in all the numbers in consideration. Like in this case, we have 8, 12, and 16. We want to find the HCF of 8, 12, and 16. So you have to look for prime numbers that we go odd through. If you can't find, you stop. So in this case, 2 goes in 8, goes in 12, and 16. That's why we use 2. Prime number 2. So 2 goes in 8, 4. 2 goes in 12, 6. 2 goes in 16, 8. Mind you, this is alternative method of finding HCF. What you should note is you have to use a prime numbers that go straight in the numbers in consideration. 2 goes in 8, 12, and 16. That's why we start with 2. 2 in 8, 4. 2 in 12, 6. 2 in 16, 8. If you also check 2, 6, and 8, what goes in 2? What goes in 4, 6, and 8? 2 goes. That's why we are using 2. 2 goes in 4, 2. 2 goes in 6, 3. 2 goes in 8, 4. So you can observe now that we have only these 2 figures. So you have to stop at this point because there is no any other number that goes in 2, 3, 4. There is no any other prime numbers. Got? No other prime number that goes straight in 2, 3, 4. 1 is not a prime number. Prime numbers are numbers that have 2 distinct factors, plus or minus 1, plus or minus itself. 1 is not a prime number because you can say factors of 1 is 1, 1. No, that is a repetition. So 1 is not a prime number because it doesn't have a 2 distinct factors. So in this case, how do you now compute your HCF? So you multiply the 2 numbers, the 2 prime numbers you used. So these are the 2 prime numbers, 2 and 2. So the HCF of 8, 12, and 16 will be 2 times 2, which gives 4. So, and if you compare with the previous answer, you will justify the claim that the HCF of 8, 12, and 16 is 4. Interesting. Oh, that's good. If you are watching this video for the first time, please do not forget to subscribe, press like, share, and try to subscribe and advise others to subscribe to this channel. Now, let's deal with another example. Example 2. What is the highest common factor of 18, 36, and 54? So, in this case, we shall use the alternative method. Using the alternative method, you can see what goes in 18, 36, and 54? 2 goes. That's why we have 2 in 18, 9, 2 in 36, 18, 2 in 54, 27. 3 goes in 9, 18, and 27. That's why we use 3. 3 in 9, 3. 3 in 18, 6. 3 in 27, 9. 3 also goes in 3, 6, and 9. We have 3 goes in 3, 1. 3 goes in 6, 2. 3 goes in 9, 3. Hope you can see that now. Is there any other number? Is there any other prime numbers that goes in 1, 2, 3? No. So in that case, the HCF will be the multiplication of all these prime numbers. This, which is 2 times 3 times 3. So 2 times 3 is 6, 6 times 3 is 18. So the highest common factors of 18, 36 and 54 gives 18. Interesting. Okay, let's proceed. What about in case of an algebraic expression? Sometimes people will be like, is it possible to find the HCF of an algebraic expressions? Yes, it's possible. It's possible. Let's go. Example 3. What is the highest common factor of 3x squared, 15xy, 27x squared y squared? So using the alternative approach, which is the approach I prefer most times, I prefer the alternative approach. So 3 goes in 3x squared, 15xy, 27x squared y squared. I observe that 3 goes there, 3 goes in 15, 3 goes in 27. So that's why I started with a prime numbers. So 3 here, I'm left with 3x squared. 3 divided by 15xy, I'm left with 5xy. If you divide, if you have a 15xy divided by 3, you have this 27x squared y square divided by 3 will give you 9x squared y squared. Is there another thing that is common to x squared, 5xy, 9x squared y squared? You observe it is x. X can go here, x will go here, x will go here. So that's why we are left with x here. We are also left with 5y. We are left with 9x y squared. Don't forget, out of the x squared, one of the x goes. That's why we have 9x y squared. Is there another figure? Is there an alphabet that goes in x, 5y, 9x y squared? No. If you choose x, x only goes there, and here there is no x here. So we are left with this. So in a nutshell, the highest common factor of 3x squared, 15xy, 27x squared y squared is 3 times x, which is 3x. So this is simple. So just have it at the back of your mind that you are looking for something that goes straight in each of these given term. Okay, so once you're able to get that, you use it. If you can't find any, stop. Okay, and you multiply what goes. So 3 times x, that's why we have 3x. So the highest common factor of 3x squared, 15xy, 27x squared y squared is 3 times x, which is 3x. Which approach do you like? I prefer the first approach. I prefer the alternative approach. But I don't know whether you prefer the first approach. Wherever you list out the factors of this number, you come up with the common factors before you now pick up the highest common factors. But for me, I prefer the alternative approach, whereby I'm able to tabulate and get things done. Drop your response at the comment section. Thanks for watching. Bye for now. See you in the next video. Bye.